CRD 3.5, Further Factoring of Second-Degree Polynomials. So now we're going back to expressions. In 3.1 and 3.2, we worked with expressions and factoring. And in 3.5, we're basically going to just do more factoring. So not a whole lot of new information here, just some harder problems to work with. I'm also going to help you with some strategies for factoring. 3.3, we moved into solving quadratics, so we had equations. And then in 3.5, we had two variable quadratics, which we were graphing. So now we're going to go back to expressions and we're going to factor them. So the first page is going to feel very much like a review, but hopefully it's just going to make your factoring skills that much stronger. There's a short list that we're going to use throughout this lesson, and it's check for GCF, look for dots, look for a perfect square trinomial, list possibilities, and test. You may not know what a perfect square trinomial is yet, but you will learn on the third slide what that is. So I'll probably just put it in our list for now, and when we get to it, I'll explain what that is. So number one, x squared plus 10x plus 24. Notice the directions say factor. All I can do with this, I can't solve it. All I can do with this is to factor it into two binomials. Is there a GCF? No, so I can check that off. Is this a dots? No, because it's not a difference and it's not two squares, so it's not a dots. It's not a PST, and I am going to basically think about all the factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 10, and I'm going to think about which ones of those are going to add and give me 10x. And actually I messed up because it should be 4 and 6, and so I'll recopy that, and that actually is my answer. X plus 4 and x plus 6. Those will give me a middle term of 10x and a last term of 24. Okay, done. Next one. All right, check for GCF. Well, I'm looking at the 4 and the 49, and I'm wondering, do they have anything common? But no. 49 is special, but it's not a fact. It does not share any factors with 4. So no GCF. Now look for dots. Okay, I see a difference. I see of 2 terms, and they're both perfect squares. So difference of 2 squares. Here it is, a difference of 2 squares. The reason why this is my favorite kind of factoring is because it's easy to see and it's easy to factor. It's just the square minus 7, the square root of each term, and then the negative and the positive. And the reason why one is negative and one is positive is because my inners will give me negative 14x and my outers will give me positive 14x, which cancel out the middle term. So this is indeed a dots. I'm going to still check and make sure that nothing can be factored any further, but I'm pretty much done. So now I'm going to go to my third example, and I'm going to check for GCF. And in fact, this time I actually found that there is one. So let me make this page a little bit. Okay, so 5 goes into everything. I'm going to pull that out. Now I've got x squared minus 8x plus 7. Okay, now the 5 stays the 5, but I can actually still factor this. So I'm going to keep going. And you do need to ask yourself if you can keep going. This is not, I already did GCF, it is not a dots, and it's not a perfect square trinomial. So I need to think of all the factors of 7. There's only 2 factors of 7, 7 and 1, so those have to work or else the trinomial is prime. But the signs, remember, will have to be minus and minus because it's negative 8x. Now this is completely factored. 5 times x minus 7 times x plus minus 1. Okay, this page, factor. I'm also going to check for GCF, look for dots, look for PST, look PST, and then list the possibilities and test. And then it asks at the bottom, do you notice a pattern? Well, guess what? I notice a pattern in all of these. Do you notice it? Yeah, they're all dots. They're all differences, and they all are perfect squares. But let's make sure we haven't missed anything. The first one, check for GCF. There isn't one. Look for dots. It's dots. So what is it going to be? X plus 1, x minus 1. Yahoo, I'm done. The next one, 100x squared minus 16. Check for GCF. Well, guess what? In this one, there is a GCF, and it's pretty important to get it out. Is it 2? Is it 4? Is it 16? I think it's 4. that would be 25x squared minus 4. Those two are relatively prime. They don't have any factors in common. So now I'm going to do this binomial times this binomial. Square root of that would be 5x minus 2, 5x plus 2. And now this cannot be factored any further, so I'm done. Next one, check for GCF. 49, remember 49 only has 1, 49, and 7, so that's it. I can't do anything, so this is basically going to factor into 7x minus 4, 7x plus 4. Done. Next one, dots. I don't see a GCF. X minus 6, x plus 6. Do I notice a pattern? Indeed, they are all dots. Okay, hopefully that was easy for you. Next, now check for GCF. There isn't one. Look for dots. There isn't one. Now we're going to be looking at the perfect square trinomials. So let's just say we didn't notice that because we don't know what it is yet. So I'm going to set up two binomials. I know x is going to go here. I know x is going to go here. My signs have to be plus and plus. And because of these, now I'm going to think about 36. Well, 36 has a lot of factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9. Haven't gotten there yet. 5 and nothing. 6 and 6. That's the one. Because 6 times 6 is 36, but 6 plus 6 is 12. So notice how I get x plus 6 times x plus 6. Well, I could also write that as x plus 6 squared. So this is a perfect square trinomial. Let me see if I can get something more exciting here. This, that didn't work out like I thought. Okay, this x squared plus 12x plus 6 is a perfect square trinomial. This is a binomial squared. That's the connection we're making on this slide. I still want to check for GCF though. I don't want to forget to do that. So next I check for GCF. No, it's not there. Then I say, okay, well, I'm going to look for dots. It's not a dots. Okay, now I'm going to look for perfect square trinomial. Well, gosh, this looks like the same pattern, only now it has a minus 12x instead of a plus 12x. Well, how could that affect what I'm doing? Well, if I took the slow route and I listed all the possibilities and I listed this out and I knew it was 6 and 6, I would realize that it was x minus 6 times x minus 6, or best written as x minus 6 squared. Another perfect square trinomial, another binomial squared. See if you can figure out the next one. 16 is a perfect square, just like 36 was. If I think the square root of 16 is 4, double of 4 is 8, I might just recognize that this is a PST, and that its factored form would be x minus 4 parentheses squared. If you don't notice this and you go the long route, that's not the end of the world. It just takes longer, that's all. Finally, my last question here. I want to check for GCF first. Is there GCF here? It feels like there might be, but there's not, because 9 doesn't share it. So now I say, is there a dots? And guess what? No dots. So now I'm going to say, is it a perfect square trinomial? Well, I'm actually not sure. But if it was, I would end up with the same thing in both parentheses when I was doing this. And it would be the square root of my first term and the square root of my last term. It would also be a minus because I have a minus there. So let's test it and see if it actually is this. If I multiply my first for FOIL, I get 4x squared. If I multiply my my outers, I get negative 6x. If I multiply my inners, I get negative 6x. And if I multiply my last, I get positive 9. When I put that all together, I get 4x squared minus 12x plus 9, which is exactly what I started with. So this actually factors into 2x minus 3 squared. Okay, this one's harder to see. So if you didn't really see the perfect square trinomial on your way in, you probably would get there anyway in the end. Okay, last slide. This is my list. This is what I'm going to follow every time. I'm going to give you 3 harder ones to do right now. Okay, and I'll do them with you. Factor. Check out for GCF. 9, 12, and 5. They don't have a GCF. Are they dots? No. Look for perfect square trinomial. Well, I already know off the bat it's not a perfect square trinomial because that is not a perfect square. 9x squared is, but 5 is not. So now I need to list the possibilities and test. I'll be honest, that's hard work. It's not the easiest method that you're going to end up doing, but it is what it is. So I'm going to set 3x and 3x here. 5 is only going to have two factors, 5 and 1 or 1 and 5. So that would be one possibility. My sign could be -5 and +1. It could be +5 and -1. That would both get me to this answer and this answer. Now, I haven't tested either one of these to see if it gives me -12x. I'm just in this list possibilities section. Okay, so that's those possibilities. Now, I could also have 9x and 1x at the beginning, right? And then 5 and 1, or 1 and 5. And again, negative or positive. And I could even change this to positive or negative. So let's just use a different color so I don't have to write it 10 times. It could be +5, -1. It could be +1 and -5, which is different. Any other possibilities? No. So basically I have 1, 2, 3, 4, 5, 6 possibilities. So now I'm going to do the testing. And I'm basically testing to see if I'm going to get this -12x. Because I already know, based on what I've listed, that the 9x squared and the -5 work out. But I don't know if the -12x works out. So this one, my inners give me -15x. My outers give me 3x, which gives me -12x. So I got it on my first try. Well, that was pretty nice. That's pretty lucky on Cindy's part. So you can stop and because you know your answer. But if you sometimes people put the best answer, the correct answer last, so you end up testing. Let's test the second one so you can see what I mean. The inside gives me +15x. The outside gives me -3x. Well, if I combine those, I get +12x, which is not my middle term. So I would have crossed that one out. That's not the answer. Then if I have 9x -5, 1x plus 1, my inners give me negative, that's an I. My inners give me -5x. My outers give me +9x, which gives me a total of 4x, which is not right. The next one, the inners give me 5x positive, and the outers give me -9x, which gives me -4x, and that's not right. And if I test these last two, those are not right either. So my final answer happened to be the one that I found in the beginning. But sometimes you have to test them all. So hopefully you won't have too many of these questions to do because they can be a little bit tedious. Next one, check for GCF. No GCF here. Look for dots. No dots. Look for PST. Definitely not a PST because neither this nor this are perfect squares. So it's got to be a test one. So let's list out the possibilities. Okay, so I could have 3x and x. I could have a 6 and a 1, plus and plus. I could have 3x plus 1 and x plus 6. Those are different, believe it or not. I could have 3x plus 2 and 3x plus 3. Nope, that's wrong. 3x plus 2 and just x plus 3. I could have 3x plus 3 and x plus 2. Now I think I've come up with all of them. So which one gives me 11? Well, this one gives me 6x on the inside and 3x on the outside. 6 plus 3 is 9. That's not it. This one gives me 1 on the inside and 18 on the outside. And that's 19, so that's not right. This one gives me 2x on the inside and 9 on the outside. That gives me 11x, so I found my answer. This one gives me 3 on the inside, 6 on the outside, which gives me 9, which is not right. So I found my answer. Excellent. Tricky, but excellent. Okay, last one. You're going to see more of these in Chapter 5, but I am going to show you how to do this one. So check for GCF. No. Check for dots. Guess what? This is a dots. Whether you can see it or not, I'm going to erase this. This is actually a difference of two squares. I'll show you. The difference part is right here. Yes, I see the other difference, but this is the difference I'm talking about. This is one of the squares, 16. This is the other square, x minus 5. So this is basically like saying a squared minus 16 squared, or sorry, minus 16, which factors into a minus 4, a plus 4. But since it's not a, it's actually x minus 5 minus 4 and x minus 5 plus 4, because I replaced a with the x minus 5. Now I can take this one step further because I basically have x minus 5 minus 4, which is x minus 9. And this one I have x minus 1 when I put the negative 5 and the 4 together. So this is my final answer. There is another way to do this where you can FOIL that out, subtract 16, and then factor it, and you would get the same answer, just doing it a different way. Good luck with the harder factoring questions.